So in this video, we'll continue our discussion on finding the volume of certain solid. And this method now is called the cylindrical shell, which is the second method we learn here. And after what we learned about the disk and the washer method, and this method conceptually is very different from the last method, and that's why the formula formed is totally different also. But I would like to emphasize that both methods have their merits in the sense that maybe for some pictures, depending on the solid you form, one method can be much easier to use than the other, and the computation can be much faster also. But in general, you have to learn both methods extremely well because the concept of them are so different. And now, let's take a look at the current picture. If you rotate this purple shaded part along the y-axis, can you imagine what kind of solid you're getting? So I hope that my drawing is not too bad, and roughly speaking, you're getting a solid like this. And now, in the current method, the way to find the volume, we'll try to use a vertical line here. You see, this line is not cutting along the axis of rotation. This line is actually parallel to the axis of rotation. And now please imagine for this vertical red line, if you try to rotate this line along the y-axis, what kind of thing are you getting in this picture? And actually what you're getting is something like this, I believe. So it's kind of like this. So basically, this part is like an empty shell. It's like things inside are empty. If you try to rotate this red line along the y-axis. And now, please think about the original concept about the integration. I've mentioned it already. Integration, you can think of it as a summation of something. And now, conceptually speaking, you can think of it like this. The volume of this solid is, informally speaking, the same as the summation of the surface area of a shell. So I would like to take a bit of time here. I'm talking about one shell here. How many shells can you form? You see, the fact is that the shell is formed based on a point from A to B, right? If you look at the leftmost point, which is A, and you take the vertical line here, it is the innermost line you take on this picture. And in that case, you're getting the innermost shell. And in the opposite end, if you take the rightmost point B and if you rotate it along the y-axis, you're getting the outermost layer. So basically, what I'm saying is that on this purple solid, you can imagine that you're trying to peel off the layer by layer in a very regular way, such that each layer is really just like a shell. And when you do it that way infinitely, because you try to cut it thinner and thinner for each slice here, and for one slice, it's really just like a line, which means you're getting just one thin layer of one shell. So in that case, we claim that the volume of solid, you can think of it as the sum of all these surface area of the shells from the innermost shells to the outermost shell. So it's from x equals a to x equals b. In that case, when you go along a to b, you're getting infinitely many shells. Each shell is kind of like this, and you know the surface area formula of this shell. So we're able to write the integration formula here as below. So this method is basically called the method by cylindrical shell because we are summing up the surface area of a shell. And please note that now for the y-axis rotation, we have to do a dx integration because of the fact that we're going along the x-axis from the innermost shell to the outermost shell from A to B. So we are summing up something from A to B. And this something inside the content of the integral is actually the surface area of a shell, right? And please recall the formula for the surface area of this shell. The fact is that if you unroll this kind of shell, if you unroll it, you are getting a rectangular shaped paper like this. And please think about the length. The area, which is basically the surface area of this shell, is the same as, of course, base times height. The base is here, the height is here. Let's think about the meaning of height. The height here is basically the same as this height. Let's come back to the picture, and I'm trying not to confuse you. This height, I use the green color now. Let's come back to this picture. It's basically this height. If I go back to this picture, it's basically this height, right? Which is essentially the height of the shell. And this height is based on the function y equals f of x. If the function is given, which means the h is basically just f of x. If you look at this length is basically the y coordinate of this point, which is based on the function y equals f of x, right? And how about the b? Maybe I use the black color here. The b, which is the base length of this rectangle. If you roll it back, basically the b is this length, which is the circumference of this circle. How to find the circumference of this circle? So I write it here. B is basically 2 pi r in terms of the formula of the circumference of the circle. The r is basically here, right? Which is the r. I think now the r is easy. If you go back to this picture, this r is basically this horizontal length, which is the x length of this point, which is based on this length, right? And this length is fixed based on this point. This point is exactly the point you choose from A to B, depending on which point you choose. Basically, the r is just x, right? It's the x length here. It depends on this point you choose. If you choose this point as x naught, then this one, this r would be just simply x naught. So it means we actually get the formula of the surface area of one shell. So I put it here, which is basically the area of this rectangle, which is b times h, and h is f of x, and b is, as I put it on the top left, which is 2 pi x. So I put the formula as 2 pi times x times f of x. That's it. Basically, that's the formula to find the volume of the solid generated by using the y-axis as the rotation. And let's do a simple example now. So please look at the current picture. I would like to get the volume formula to find the volume for the solid, which is generated by using this purple shaded part, and also using the y-axis as the axis of rotation. And please look at the formula we have learned. And based on this formula, I try to write it down here. And A, B now are the leftmost point and the rightmost points. And let's say it is 3 and 5. Doesn't matter as an example. So now, what is the content inside the integral? It should be 2 pi x times something, and this one is the height of the shell. You see, one shell is now formed by one line like this, right? So this height is basically based on the y coordinate of this point, which is a point sitting on the curve y equals x cubed plus 1. So I'll just put it here, which is x cubed plus 1. And basically, that's the volume formula of the solid formed by this picture, and also the y-axis as a rotation axis. And I trust that you're able to do this calculation, but try to write the steps down. So please look at my steps here. I trust that you're able to finish this simple computation, and that's the end of this problem.